Howdy, seventh grade. Today we're going to talk about polynomials. Technically, the students will be able to for today is that you will be able to use, identify, add, and subtract polynomials, but that seemed like a lot to write, so I'm just sticking with polynomials as the title here. But before we get into polynomials, we know that poly here means many, and if we have many of something, they're kind of hard to look at. So we're going to start with a monomial and say what that is. So what a monomial is a bunch of stuff multiplied together. And some examples of this, together. There we go. Some examples of this would be if I had 2x, that's 2 times x, that's a monomial. If I had 5xy, also monomial. 3x squared, 2ab. Basically, a bunch of stuff multiplied together, no matter how you do it. This is a monomial, that's monomial, that's monomial, and that is a monomial. So that is how that works. I feel like that's a fairly simple definition. If you got a bunch of stuff, multiply it together, you got yourself a monomial. What a polynomial is it, let me move this down, awesome. So a polynomial, I'll go back to white, just so we're keeping some sort of color scheme here. So what a polynomial is several monomials added together. So a polynomial is when you get a bunch of these monomials and you add them together. So an example would be like 3x squared plus 2x plus 5. All of these are monomials. Mono, as in one. But you put the 3 ones together and you have many things, and so we call it a polynomial. There's a bunch of different numbers added together. So the first thing I want to make sure that we know is how to find the degree of one of these things. So there is going to be quite a bit of vocab to start here, but we're going to start with degree of a monomial. And degree is kind of a way to say the size of the monomial. So the size of your monomial is going to be, wait for it, the sum of the exponents of the variables of the monomial, which is a mouthful, but we'll look a little bit at what that means. So, now a quick couple examples. My first example here is going to be if I have 3x squared y squared, my degree is going to be the sum, which means I'm adding the variable or the exponents of the variables. The exponent on my x is 2, the exponent on my y is 2, and I end up saying that this has degree 4. And I want to show you guys one real quick strange thing that happens when we do this with another example, is that sometimes we'll get something that looks like 3ab squared c cubed. So now we're going to add up the exponents of the variables, and I see I have a 3 right there. I have a 2 right here. But this a, if there's nothing, if it's not showing an exponent, there's a 1 here that doesn't have to be written. Sometimes we write it, sometimes we don't. Most times we don't. So if it's not written, anytime you see a variable without an exponent, its exponent is actually 1. And we have to bring the 1 right over here. And by doing that, we can make sure that we have everything we need. So the degree of this would be 3 plus 2 plus 1, which is 6. And just like that, we are golden and good to go. So that's how you find the degree, not what I meant to do, scroll down. That's how you find the degree of a polynomial, but of a monomial, but how do you find the degree of a polynomial is a little bit different. It's also a lot easier. So the degree of a polynomial is the biggest, the largest degree of a monomial in the polynomial. So we'll do a quick example of this just so you'll see what that looks like. But we're looking for the biggest degree of a monomial in the polynomial. So if I have 3x squared a cubed plus 2x cubed plus 5a, this right here has a degree of 2 plus 3, 5. This has a degree of 3, and this has a degree of that 1 that we don't always write. So this one is going to be the biggest monomial, biggest degree. And because of that, we say we have a degree 5 polynomial, because that is the biggest degree of any of the monomials inside the polynomial. So all we're doing is we're looking for the exponents, we're adding them up, that's our degree. So now that we can tell what a polynomial is and kind of use it to figure out the degree of something, I did also say we were going to add and subtract these things, which is surprisingly easy. It is combining like terms. So let's look at that, combining like terms. And there's a rule for this, which is we can only add the same variables together. We can only add the same variables together. What that means, kind of real life looking, is if I have 3 apples plus 2 apples, I will end up with 5 apples. If I have 3 apples and 2 oranges, I really don't know. I have 3 apples and 2 oranges. So because of that, there's not too much we can do if we have different variables, because we're adding apples and oranges, and that just doesn't work. So let's look at a quick example of what this might look like. If I have x cubed plus 2x squared plus 5x minus 1, and I want to add that polynomial to this polynomial, which is going to be 5x squared minus 2. I drew that parenthesis over here way too far out. What I'm going to want to do is I'm going to line this up kind of like we line up digits when we're lining up digits for long subtraction problems. So I see that I have an x cubed on top. Sorry, let me make sure I'm adding these. I have an x cubed up top, and that's going to be 1x cubed. I don't have any x cubed on bottom, so I'm going to put a 0x cubed there, because 0 times x cubed is 0, and that's what I got. Up top, I have 2x squared, and on bottom, I have 5x squared. So that was these two numbers here. Up top, I have a 5x. On the bottom, I don't have anything with just an x on it. That's not here. So I'm going to put plus 0x. Up top, I have minus 1. On the bottom, I have minus 2. So if I am adding these things together, I'm going to start by saying, well, 1 plus 0 is 1, and x cubed is going to stay the same. This is me saying I have 1 apple plus 0 apples is going to give me 1 apple. So x cubed stays the same. Do not change the variable when you are adding. Don't do it. It will make me sad inside, and that's no fun for anybody. So we'll go to the next one. I have a 2 and a 5. That gives me 7. Oranges and oranges stay oranges. 2 oranges plus 5 oranges is 7 oranges. We're going to keep that right there and keep on chugging along. 5x and 0x is going to be 5x. And we're going to subtract negative 1 minus 2 is negative 3. Just like that, we are done. So the key to this is going to be making sure that we only combine like terms, because if we try to combine unlike terms, it's not going to quite work out. And just to keep whatever variables we have there so that they don't mess with anything. In any case, I will see y'all in class tomorrow. Have a wonderful day.